Data erasure is a software-based method of overwriting the data that aims to completely destroy all electronic data residing on a hard disk drive or other digital media. Permanent data erasure goes beyond basic file deletion commands, which only remove direct pointers to the data disk sectors and make the data recovery possible with common software tools. Unlike degaussing and physical destruction, which render the storage media unusable, data erasure removes all information while leaving the disk operable, preserving IT assets in the environment. New flash memory Euro-based media implementations, such as solid-state drives or USB flash drives, can cause data erasure techniques to fail, allowing remnant data to be recoverable. Software-based overwriting uses a software application to write a stream of meaningless pseudorandom data onto all of a hard drive's sectors. There are key differentiators between data erasure and other overwriting methods, which can leave data intact and raise the risk of data breach, identity theft and/or failure to achieve regulatory compliance. Many data eradication programs also provide multiple overwrites so that they support recognized government and industry standards. Good software should provide verification of data removal, which is necessary for meeting certain standards. To protect the data on lost or stolen media, some data erasure applications remotely destroy the data if the password is incorrectly entered. Data erasure tools can also target specific data on a disk for routine erasure, providing a hacking protection method that is less time-consuming than software encryption. Hardware firmware encryption built into the drive itself and/or integrated controllers is now a popular solution with no degradation in performance at all. Presently, dedicated hardware firmware encryption solutions can perform a 256-bit full AES encryption faster than the drive electronics can write the data. Drives with this capability are known as self-encrypting drives. They are present on most modern enterprise-level laptops and are increasingly used in the enterprise to protect the data. Changing the encryption key renders inaccessible all data stored on a SED, which is an easy and very fast method for achieving a 100% data erasure. Theft of an SED results in a physical asset loss, but the stored data are inaccessible without the decryption key, which is not stored on a SED. Importance: information technology assets commonly hold large volumes of confidential data. Social security numbers, credit card numbers, bank details, medical history and classified information are often stored on computer hard drives or servers. These can inadvertently or intentionally make their way onto other media such as printer, USB, flash, zip, JAS, and/or EV drives. Data breach increased storage of sensitive data, combined with rapid technological change and the shorter lifespan of IT assets, has driven the need for permanent data erasure of electronic devices as they are retired or refurbished. Also, compromised networks and laptop theft and loss, as well as that of other portable media, are increasingly common sources of data breaches. If data erasure does not occur when a disk is retired or lost, an organization or user faces a possibility that the data will be stolen and compromised, leading to identity theft, loss of corporate reputation, threats to regulatory compliance and financial impacts. Companies have spent nearly $5 million on average to recover when corporate data were lost or stolen. High-profile incidents of data theft include, Card System Solutions, credit card breach exposes 40 million accounts. Lifeblood, missing laptops contain personal information including dates of birth and some social security numbers of 321,000. Hornaford, breach exposes 4.2 million credit, debit cards. Compass Bank, stolen hard drive contains 1 million customer records. University of Florida College of Medicine, Jacksonville, photographs and identifying information of 1,900 on improperly disposed computer. Oklahoma Corporation Commission, server sold at auction compromises more than 5,000 social security numbers. Regulatory compliance strict industry standards and government regulations are in place that force organizations to mitigate the risk of unauthorized exposure of confidential corporate and government data. Regulations in the United States include HIPAA, FACTA, GLB, Sarbanes-Oxley Act, and payment card industry data security standards and the Data Protection Act in the United Kingdom. Failure to comply can result in fines and damage to company reputation, as well as civil and criminal liability. Preserving assets in the environment data erasure offers an alternative to physical destruction and degaussing for secure removal of all the disk data. Physical destruction and degaussing destroy the digital media, requiring disposal and contributing to electronic waste while negatively impacting the carbon footprint of individuals and companies. Hard drives are nearly 100% recyclable and can be collected at no charge from a variety of hard drive recyclers after they have been sanitized. Limitations: data erasure may not work completely on flash-based media, such as solid-state drives and USB flash drives, as these devices can store remnant data which is inaccessible to the erasure technique, and data can be retrieved from the individual flash memory chips inside the device. Data erasure through overwriting only works on hard drives that are functioning and writing to all sectors. Bad sectors cannot usually be overwritten, but may contain recoverable information. Bad sectors, however, may be invisible to the host system and thus to the erasing software. Disk encryption before use prevents this problem. Software-driven data erasure could also be compromised by malicious code. Differentiators: software-based data erasure uses a special application to write a combination of ones and zeros onto each hard disk drive sector. The level of security depends on the number of times the entire drive is written over. Full disk overwriting while there are many overwriting programs, only those capable of complete data erasure offer full security by destroying the data on all areas of a hard drive. Disk overwriting programs that cannot access the entire hard drive, including hidden locked areas like the host protected area, device configuration overlay, and remapped sectors, perform an incomplete erasure, leaving some of the data intact. By accessing the entire hard drive, data erasure eliminates the risk of data remanence. Data erasure can also bypass the BIOS and OS. Overwriting programs that operate through the BIOS and OS will not always perform a complete erasure due to altered or corrupted BIOS data and may report back a complete and successful erasure even if they do not access the entire hard disk, leaving the data accessible. Hardware support data erasure can be deployed over a network to target multiple PCs rather than having to erase each one sequentially. In contrast with DOS-based overwriting programs that may not detect all network hardware, Linux-based data erasure software supports high-end server and storage area network environments with hardware support for serial ATA, serial attached SCSI and fiber channel disks and remapped sectors. It operates directly with sector sizes such as 520, 524, and 528, removing the need to first reformat back to 512 sector size. Standards Many government and industry standards exist for software-based overwriting that removes the data. A key factor in meeting these standards is the number of times the data are overwritten. Also, some standards require a method to verify that all the data have been removed from the entire hard drive and to view the overwrite pattern. Complete data erasure should account for hidden areas, typically DCO, HPA and remapped sectors. The 1995 edition of the National Industrial Security Program Operating Manual permitted the use of overwriting techniques to sanitize some types of media by writing all addressable locations with a character, its complement, and then a random character. This provision was removed in a 2001 change to the manual and was never permitted for top-secret media, but it is still listed as a technique by many providers of the data erasure software. Data erasure software should provide the user with a validation certificate indicating that the overwriting procedure was completed properly. Data erasure software should also comply with requirements to erase hidden areas, provide a defects log list and list bad sectors that could not be overwritten. Data can sometimes be recovered from a broken hard drive. However, if the platters on a hard drive are damaged, such as by drilling a hole through the drive, then the data can only theoretically be recovered by bit analysis of each platter with advanced forensic technology. Number of overwrites needed Data on floppy disks can sometimes be recovered by forensic analysis even after the disks have been overwritten once with zeros. This is not the case with modern hard drives, according to the 2006 NIST Special Publication 800-88 Section 2.3. Basically, the change in track density and the related changes in the storage medium have created a situation where the acts of clearing and purging the media have converged. That is, for ATA disk drives manufactured after 2001, clearing by overwriting the media once is adequate to protect the media from both keyboard and laboratory attack. According to the 2006 Center for Magnetic Recording Research tutorial on disk drive data sanitization document, Secure Erase does a single on-track erasure of the data on the disk drive. The U.S. National Security Agency published an information assurance approval of single-pass overwrite, after technical testing at CMRR showed that multiple on-track overwrite passes gave no additional erasure. Secure Erase is a utility built into modern ATA hard drives that overwrites all data on a disk, including remapped sectors. Further analysis by Wright et al. Seems to also indicate that one overwrite is all that is generally required. E-waste and information security. E-waste presents a potential security threat to individuals and exporting countries. Hard drives that are not properly erased before the computer is disposed of can be reopened, exposing sensitive information. Credit card numbers, private financial data, account information and records of online transactions can be accessed by most willing individuals. Organized criminals in Ghana commonly search the drives for information to use in local scams. Government contracts have been discovered on hard drives found in Igbogbloshi, the unregulated e-waste center in Ghana. Multi-million-dollar agreements from United States security institutions such as the Defense Intelligence Agency, the Transportation Security Administration and Homeland Security have all resurfaced in Igbogbloshi. See also. References